Hi friends, this is Arya Davadkar and today I am going to have a discussion on the topic trigonometry. Trigonometry is derived from the Greek word trigon, which means triangle. Trigonometry is the branch of mathematics that deals with the relationship between sides and angle of a triangle. There are basically 6 important trigonometric ratios or trigonometric functions, which are sine, cosine, tangent, cosecant, secant and cotangent. We are going to understand what are the different properties and relations that exist between these trigonometric ratios. So we have a right angle triangle present here. We have the angles as theta, alpha, and this angle will be 90 degree because it's a right angle triangle. Now let us name the sides. Let this side be y, which is the base. Let this height be x of length x and the hypotenuse of length z. Okay, now there are certain terminologies that we have for in trigonometry, that is opposite side, adjacent side, hypotenuse. We know exactly what is hypotenuse. So in this we know that from Pythagoras theorem that z square is equal to x square plus y square. This is the Pythagoras theorem. Okay, now for any angle theta, the side which is opposite to that angle will be our opposite side. That means this will be our opposite side for theta, and this side of length y will be the adjacent side. Now sine of any angle is known as sine theta, which will be opposite side upon hypotenuse of a right angle triangle. So in this case it will be length x upon length z. Similarly, cos theta or cosine of theta will be adjacent side upon hypotenuse for a right angle triangle, which will be equal to length y upon length z, which is y by z. Similarly, tan theta will be equal to opposite side upon adjacent side, which will be equal to x, length x upon length y. These are the three fundamental trigonometric ratios. Now we can obtain other three ratios, which are cosec, sec and cot theta from the above trigonometric ratios. The relations are namely cosec theta is equal to 1 by sin theta, which will equal to hypotenuse upon opposite side of a right angle triangle, which will be equal to length z upon length x, which is z by x. Sec theta is equal to 1 by cos theta, which will equal to hypotenuse upon adjacent side, which is equal to z by y. Similarly, cotangent of theta or cot theta will be equal to 1 by tan theta, which is equal to adjacent side upon opposite side, whose value will be y upon x. Now, in case you will be wondering what exactly what are the trigonometric ratios existing for alpha, so we need to first understand that what are the different opposite side or adjacent side for alpha. So for alpha, the opposite side will be y. This is the opposite side for angle alpha. So this will be the opposite side for alpha. And this length side of length x will be the adjacent side, and z will be hypotenuse. Okay, now let us now understand what is sine alpha. Sine alpha will be opposite upon adjacent, opposite upon hypotenuse. So for alpha, opposite side will be of length y upon hypotenuse z. Similarly, cos alpha will be adjacent side upon hypotenuse, which will be equal to x by z, and tan alpha will be equal to opposite side upon adjacent side, which will be equal to y upon x, and cosec of alpha will be 1 by sin alpha, which will equal to z by y. Similarly, sec of alpha will be equal to 1 by cos alpha, which will be equal to z by x, and similarly cot of alpha will be equal to 1 by tan alpha, which will equal to x by y. Now if we compare with these values, we will get certain relations, which will be sin theta is equal to cos alpha, cos theta is equal to sin alpha, tan alpha is equal to cot theta, cot alpha is equal to tan theta, Also sec alpha is equal to cosec theta, cosec alpha is equal to sec theta. These are the relations we are getting. Now if we talk about the triangle, we know that sum of all the angles of a triangle is 180 degrees. So we have a 90 degree triangle. Now we have proved above relations for theta and alpha of a right angle triangle. Now we know that sum of all the angles of a right angle triangle is 180 degree. So we have one angle of 90 degree, other of alpha, other of theta. So sum will be 90 plus alpha plus theta, which is equal to 180 degree. So we get above relation theta plus alpha is equal to 180 minus 90. If we send 90 that way, we will get 90 degree. So basically theta and alpha are complementary angles. So complementary angles are angles whose sum is equal to 90 degree. We will get a relation that alpha is equal to 90 degree minus theta. Okay. Now if we substitute this 90 degree minus theta in the above relation, we will get certain new relations such as sin theta is equal to cos of 90 minus theta. Similarly, cos theta is equal to sin of 90 minus theta. Tan 90 minus theta is equal to cot theta, and cot of 90 minus theta is equal to tan theta. Sec of 90 minus theta is equal to cosec theta, and similarly cosec of 90 minus theta is equal to sec theta. So from this above result we can conclude that for a pair of two complementary angles, theta and alpha, pair of complementary angles, the sine of one angle will be always equal to the cosine of other angle. Similarly, tan of any angle will be equal to cot of any other angle. Sec of any angle will be equal to cosec of any other angle. So these are the relations we get, that for two complementary angles theta and alpha, whose sum theta plus alpha is equal to 90 degree, sine of angle sine of theta will be equal to cos of alpha. Similarly, cos of alpha will be equal to sine of theta, and vice versa for all other trigonometric ratios which we have proved here. So now let us understand what are different ratios or relations that exist for the trigonometric ratios or functions. So one of them will be tan theta is equal to sin theta upon cos theta. Now for this you can refer to this page where you can see that sin theta is opposite upon hypotenuse, so which is x by z, and cos theta is y by z. Now sin theta upon cos theta will give us x by y. So now from this relation we get x by y for tan theta, which is equal to this. So hence we have proved that sin theta upon cos theta is equal to tan theta. Similarly, we know that tan theta is equal to cot theta is equal to 1 by tan theta. So therefore cot theta can also be written as cos theta upon sin theta. Cosec theta is equal to 1 by sin theta, which I have written here. Sec theta is equal to 1 by cos theta, which is also written. Now there are basically three fundamental trigonometric identities, which are sin square theta plus cos square theta is equal to 1, 1 plus tan square theta is equal to sec square theta, 1 plus cot square theta is equal to cosec square theta. Now we know that these identities are very useful for solving any trigonometric problems. Now let us first prove how we get the proof of this trigonometric identity. Now let's start with the first identity. We know that we have given that sin square theta plus cos square theta is equal to 1. Now let us start from the LHS side, left hand side, this side. We know that sin theta for this right angle triangle where we have written as x by z, which is equal to sin theta is equal to x by z. So sin square theta will be x upon z whole square, plus cos theta is equal to y by z. So it will be y by z whole square. We write it here as x square plus y square upon z square. Now as this is a right angle triangle of x, y and z, so our relation will be x square plus y square is equal to z square. So sum of these two sides will be equal to the hypotenuse, as this is the 90 degree angle. So x square plus y square is equal to z square. If we substitute it here, it will be z square upon z square is equal to 1. Therefore, LHS is equal to RHS. Hence, we have proved our trigonometric identity that sine square theta plus cos square theta is equal to 1. Now, after proving the first identity, now let's prove the second and third identity respectively. Now, second identity is given as 1 plus tan square theta is equal to sec square theta. Now, from this above relation, that tan theta is equal to sin theta by cos theta. Now, first let us, before moving forward, let us first solve LHS, that is 1 plus tan square theta. We will substitute tan theta as sin theta upon cos theta. So it will be like sin theta upon cos theta whole square. After expanding this, we will get this as 1 plus sin square theta upon cos square theta. Now, after rearranging, we will get cos square theta plus sin square theta upon cos square theta. Now, this, if you look at this numerator, sin square theta plus cos square theta, this is our first identity, that is sin square theta plus cos square theta is equal to 1. So we can directly substitute this value as 1 by cos square theta. Also, we know that 1 by cos theta is equal to sec theta. So this 1 by cos square theta will become sec square theta, which is equal to RHS. Hence, LHS is equal to RHS. Hence, we have proved our identity that 1 plus tan square theta is equal to sec square theta. Similarly, we will prove the third identity, which is 1 plus cot square theta is equal to cosec square theta. Here we will solve the LHS. Now, we know that cot theta is 1 by tan theta, which is also cos theta upon sin theta. So we will substitute that here. We will get 1 plus cos theta by sin theta whole square. Now, after squaring this term, we will get this 1 plus cos square theta upon sin square theta. On rearranging, we will get cos square theta plus sin square theta upon sin square theta. Now, again, this thing is our first identity, that is sin square theta plus cos square theta is equal to 1. So we will substitute it here. So our numerator will become 1, which will be 1 by sin square theta. And also we know the relation that 1 by sin theta is equal to cosec theta. So again, this 1 by sin square theta will become cosec square theta. Hence, this is equal to LHS is equal to RHS. Hence, we have proved the identity, third identity, as that is 1 plus cot square theta is equal to cosec square theta. So this was the end of our video on basic trigonometry. Now I would also like to make new videos on the trigonometry, on also different topics of maths or physics. Thank you. Please like and share the video.